Hello, Pre-Algebra. Coming to you with a very tough quiz. So I'm actually going to go through and probably do all of these just because it really is a tough quiz. These formulas are not easy, and trying to wrap your head around translations and reflections and it's tough. So I want to work with you and show you guys the steps of what I'm going to do, and hopefully it'll make a lot more sense. Again, I care a lot more about understanding than the fact that you get every single one on your own. So for numbers 1 and 2, we are using the distance formula. Now the distance formula, again, is distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. So it's the square root of that whole business, okay? Now I'm going to designate this as point 1, this is point 2. So my distance is going to be square root of x1 minus x2, so 2 minus 5 squared plus 8 minus 4 squared. Again, that's going to give me the square root of 2 minus 5 is negative 3 squared, plus 8 minus 4 is 4 squared. So that'll be the square root of, again, the reason why I do that is so that way my line is the right amount of length. Negative 3 squared is 9 plus 16. Well, that's going to equal the square root of 25. So my distance is 5. I'm going to use the same formula over here. Distance equals square root of 3 minus negative 2. 3 minus negative 2 squared plus negative 8 minus negative 6 squared. Okay. It's going to equal square root of 3, okay, I'm subtracting a negative, so I'm going to add it. 3 plus 2 is 5 squared plus, again, this is going to be adding it. Negative 8 plus 6 is negative 2. Negative 2 squared. That's going to be the square root of 25 plus 4. So that's going to be the square root of 29. Now, you might be saying, well, Mr. Bolger, the square root of 25 is plus or minus the square root of 5. Although that's true, we cannot have, oh, I'm sorry, not the square root of 5, just plus or minus 5. Plus or minus 5. Well, it's true, but we cannot have a negative distance. Right? You can't walk negative 5 feet. You just can't do that. So we're only going to address the positive one. So although this would be plus or minus the square root of 29, our distance is just going to be the square root of 29, the positive square root of 29. Okay? All right, numbers 3 and 4. We are looking for the midpoint of segments with these separate endpoints. The midpoint formula, this is where we have an x value, comma, y, but our x value is going to be x1 plus x2 divided by 2, right? We're taking the average of these, comma, y1 plus y2 divided by 2. Okay. Okay, so my midpoint here, again, x comma y, negative 6 plus 4 divided by 2, comma, 4 plus 12, 4 plus 12 divided by 2. And I could simplify that, negative 6 divided by, negative 6 plus 4 is negative 2 divided by 2, comma, 16 divided by 2. So my midpoint will be at negative 1, comma, 8. So again, I've just simplified this x comma y. Here, my midpoint will be 3 plus negative 4, 3 plus negative 4, divided by 2, comma, negative 2, negative 2, plus negative 2, divided by 2. That'll equal negative 3 plus negative, 3 plus negative 4 is negative 1 over 2, comma, negative 2 plus negative 2, so negative 2 minus 2 is negative 4 over 2. So my midpoint will be at negative 1/2, comma, negative 2. Okay, so here are my two midpoints. Alrighty. Number 5. State the coordinates of x prime. So this is a shape, rather a point, because it is the reflection of x. So if we have, let's see, let me use my handy dandy little eraser guy. If we have a point x at 3, 4. So 1, 2, 3, 1, 2, 3, 4. And it's an x prime. Let's see, this is x. Okay, so this is what we're working with right here. Right, we see it's at 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. And it is and x prime, that's what the little apostrophe means. It's the reflection of 3, 4 through the x-axis. So it's going not over the y-axis, but the x-axis right here. And so my x value is going to be the same, but it is 1, 2, 3, 4 steps away. It's going to reflect over 1, 2, 3, 4 steps away. So this is going to be x prime, which has the same x value, 3, but now I'm at negative 1, 2, 3, 4, negative 4. So it reflects across the x-axis to the coordinates 3, -4. Okay. Again, the reason why I'm doing this is because all this reflection stuff, man, if it's hard to visualize this kind of stuff. I mean, I had to get a whiteboard just to make it visual for us. If you want, please, you could draw this out, at least the points on a little grid that you draw yourselves. Right, I could have drawn one here. 1, 2, 3, 4. 1, 2, 3. So this would be x, and then -1, 2, 3, -4. This would be x prime. Okay. Y, x. All right, moving on. Again, this one is tricky. Use the graph to reflect the triangle through the x-axis and then the y-axis. So it's first step, and then the y-axis. This is our second step. State whether the result is a translation or a rotation. So if it's going to be a translation, then it's going to look like this, you know, A, B, C, with the right angle kind of pointing in this direction. And it would just be moved over here or moved somewhere. But if it's a rotation, then it's turned. Right, that's the distance of this reflecting or this translating like that, or this rotating like this. See the difference is now it's kind of swinging around. That's rotation, but translation is just picking up, not changing direction. Nope, just picking up and moving. That's translation, picking it up, moving it. Rotation is turning it, right? Just like a clock rotates. Okay, so first we are going to reflect it through the x-axis. So first, let's see, this point C is going to stay the same because it's just going to kind of flop over like that. So let's see, it's 1, 2 steps up, so it's now going to be 1, 2 steps down for point A. And then 1 step over for point B. So C doesn't move, which is nice. Right, so this is the mirrored image. I was talking a lot about this yesterday. This is the mirrored image. Okay, and now it's going to, then the y-axis. Now it's going to do the mirror image thing over the y-axis. Okay, but my A is 2 steps away from the y-axis, so it still needs to be 2 steps away from the y-axis here. Again, C is 2 steps away from the y-axis, so it needs to be 2 steps away from the y-axis here. B is 1 step further than A, so it's going to be like that. Okay, so this is our final rotation, or our final reflection. And it does look like a rotation because this first one, right, this original, twists around to meet it like so. So I would say this is a rotation. This one was really difficult. But think of it like this. So if my triangle here is a piece of toast and it has jelly on it. So let's say this is my piece of toast. And it has jelly on it. And I'm actually going to draw this jelly like so. Now, if I were to reflect it across the x-axis, well, I need to fold it, the paper, at the x-axis. And I'm going to swing this guy over, and I'm going to smush it down right along the x-axis there. And we're going to see jelly right here. And it's just going to be just kind of smushed, just like that, right? So that's what these reflection things mean. When it says across the x-axis, imagine you folding your paper along that axis and then jelly getting on the other side of the paper. This looks like it's raspberry jelly, maybe strawberry. Anyway, that doesn't matter. Okay. Backside, we are on number 7. So we are looking at this equilateral triangle for these numbers. And this is asking about rotational symmetry. It's asking about all sorts of different stuff like that. So let's, before we get to the questions, let's look at our shape here. Now, again, we remember this is from 12.8, so this is all yesterday's notes. Different shapes having lines of symmetry. So let's look at a triangle. Well, I can't fold it across lines. That doesn't make sense, but it looks like it. And I know that it's equilateral, so all these sides are the same length. So if I fold it right down the middle there, right, pretending that I could draw down the middle, then that is one of my lines of symmetry. Right? Because if I fold it here, right, if I have jelly on this side, and if I fold it along that line, I'm going to have jelly in the same exact shape over here. Well, if that's the case, then if I look at the shape vertically like this, same line of symmetry, and same with this guy. Okay, so that's total of 3 lines. Oh, sorry. 3 lines of symmetry. Okay, that's where I wanted to start. Now let's look at this. All right, number 7. State all degrees of rotational symmetry. So remember yesterday when I had the square and I looked to rotate it and how far it would have to go before it fit the original outline? Well, how far am I going to have to rotate an equilateral triangle before it fits itself again? Now, it gave us a formula, and what we can do is we could divide 360 by our lines of symmetry, and we have 3 lines of symmetry. So we would need to rotate a triangle 120 degrees before it lines up again. 120 degrees. Number 8. Does the feature exhibit a point of symmetry? Remember, a point of symmetry is if the shape has more than one line of symmetry, that point of symmetry will be where those lines intersect, so right here. That is our point of symmetry. Yes. Yes, it does. How many lines of symmetry does the figure have? 3, booyah. If one endpoint of the line segment is 3, 2, and the midpoint is 5, 9, then what is the other endpoint? Oh, good gravy. This is a tough one. Okay, so I'm going to pull out my trusty, handy-dandy whiteboard. You guys could just draw this on your page, but this is to, so I don't have to draw all these lines. We all know how pretty that would be. So my first point is at 3, 2. 3, 2. And the midpoint, oh, good gravy. That's just a midpoint. That's not another point. That's not the other endpoint. That's the midpoint. So the midpoint is at 5. 1, 2, 3, 4, 5, comma, 4, 5, 6, 7, 8, 9. I'm glad I have enough. 5, 9. So this is, let's call this endpoint A, and this is my midpoint. That's not even another one. What's this? How are we going to figure this out? Well, what I'm going to do is I'm going to figure out the distance. Oh, that brown is really disappointing. Distance. I'm going to find my distance and then multiply by 2. And that's then I'm going to have to add that to figure out all the other ones. Well, now it's not actually asking me for the length, the total length. It's just asking me to find out the midpoint. So let's see if I could do some other fancy footwork. If between here, maybe I don't need to do the distance. See, this is why you guys should always draw diagrams, so that way you can see it and figure it out. So if I'm going over 2 just to get to the midpoint, that means I'll have to go over 4 to get to my x2. And if I'm going up, let's see, between 9 and 2, I'm going up 7 for the midpoint. That means that I'll have to go up 14 for my y2. Okay, well, so again, I'll write that on my paper just because I could hear you guys go, what? I actually heard that in Josiah and Tyler's voice, so if that tells you how much I miss you guys. Okay, so so my x1 is 3, right? Boom. And my y1 is 2. In order to get to the midpoint, I'm going over 2 spaces to get to M1, which is 5. And between y1 and my midpoint, I'm going over 7 steps to get to my midpoint. I don't need to call that M1, which is 9. Okay, so I'm just using all this information. Now, in order to get to x2, I'm going to move over another 2 steps. And I'm going to go from 3, 2 steps to 5, 2 steps to 7. Again, this is where geometry is a lot more spatial mindset. There's not actually a formula to do this. We're just kind of figuring things out, using diagrams, thinking out loud. Okay, so for our y, we're going from 7 places to our midpoint at 9, but we want to get to y2, and we're moving another 7 steps. So 2 plus 7 is 9. 9 plus 7 is 16. So the other endpoint of this line segment is 7, 16. Hadassah, I could hear you go, wow. I know it's hard. That's why I'm doing it with you guys. Okay. I'll still call this extra credit. What we're going to be doing is do the distance formula. You'll have to do it 3 times. First one, A, B. Second one, B, C. And third one, A, C. A, B, B, C, A, C. And tell me all the different lengths. You could draw it out. Right, you could draw it out. I don't know what it looks like. I don't know if it's obtuse or if it's acute. I don't actually know. You'll have to figure that out. It might be a right triangle. I don't know. Tell me. Tell me. Do the work. Show me. Otherwise, this has been my longest video, guys. I hope it's helped. I hope this has answered your questions. Know that I love you.